Hello, good morning. I'm discussing crystal field theory. Crystal field theory, a modification of valence bond theory, was proposed by Hans Bethe in 1929 and refined by Jones, Hasbrook, Van Vleck in 1935. It explains the interaction between a central metal ion and surrounding lesions through electrostatic forces. Crystal field theory accounts for key properties of coordination compounds such as color, magnetism, and electronic structure by describing the splitting of d orbitals in different Lagrange fields. Basic postulates of crystal field theory. The crystal field theory based upon the following basic assumptions. The interaction between the central metal and lesion in the complex is considered to be purely electrostatic, that is, ionic type of model. Crystal field theory regards the complex as the combination of central metal atom or ion surrounded by the other ions, molecules called lesions, which are considered as the point charge or point dipoles. Complexes are formed when the central cation attracts electrically the lesions, which may be either anions or dipole molecules. If the lesion is negatively charged, anion introduction, and if the lesion is the neutral, anion dipole introduction takes place. The electrons of the metal cation and the lesions do not mix or share, that is, there is no any orbital overlap between the metal and lesion. In an isolated metal cation, and the 5d orbitals have same energy and also termed as degenerate orbitals. When the lesions approach the central metal cation, which is negative in, the electrons in the cation and those of the lesions are entirely repulsive. Due to this repulsive force, the splitting of the d orbitals of metal cations into two groups of different energy takes place, called as crystal field theory. In an isolated metal cation, the 5d orbitals have same energy and also termed as degenerate orbitals. When the lesions approach the central metal cation, which is negative in, the electrons in the cation and those of the lesions entirely repulsive. Due to this repulsive forces, the splitting of the d orbitals of metal cations into two groups of different energy takes place, called as crystal field theory. Degenerate d orbitals of isolated gaseous metal atom or ion, region field, T to the set and plus EG set. The crystal field splitting in d orbitals into different energy levels mainly depends upon the number of lesions, spatial arrangements, nature of lesions, etc. And the crystal field theory is tried to describe the effect of the electrical field of neighboring ions on the energies of the valence orbitals of an ion in a complex. Types of d orbital. In the d orbital, there are 5 different types of spatial orientation: dxy orbitals, lobes in between x and y axis; dyz orbital, lobes in line between y and z; dzx orbital, lobes lie in z and x; dx square, lobes lie along the xy axis; dz square, lobes lie along z axis. On the basis of orientation of lobes, the orbitals are grouping into two sets. T to the set, the orbitals which have their lobes in between the axes are called non-axial orbitals. These are dxy, dyz, and dyz, and are termed as T to the set, triply degenerate sets. EG sets, the orbitals which have their lobes along the axis, called axial lobes, and these are dx square, y square, and dz square, and are named as EG sets, doubly degenerate sets. Okay, it's all about crystal field theory and basic postulates of crystal field theory. Thanks for watching and request you all like, comment, share, and subscribe. Thank you for your patience. That's no bye bye. See you again.